In the previous video, we took a look at what the basic sine function looks like. And remember, it was a periodic function starting at 0, 0. Domain was from negative infinity to infinity. The height was from -1, or the range was from -1 to +1. What if we start shifting that around? All right, so let's say that we have a sine function of this form. Okay, so A, B, C, and D are going to be these coefficients that are going to be the parts of the sine function, or just the constant that are going to try to shift this function and change things around. So, four characteristics that we're interested in. First of all, the amplitude. The amplitude just tells us how high and how low the function go. Okay, so basically it determines the max and the minimum of the graph of the function. I'm not sure what happened to the word function there, but should say the word function there. All we have to do is just look at A, and the amplitude is the absolute value of A. If A is less than 0, then the graph gets reflected in the x-axis. Remember that a general sine function has a period of 2 pi, okay? It's like the regular period, okay? But this coefficient b in front of the x is going to affect the period, okay? So it's basically either going to shrink or expand the sine function, okay? The wavelength, or the period of it, excuse me. And so to be able to find the period, we just take 2 pi divided by b. The phase shift is going to tell you how far left or right. It's the same thing as a horizontal transformation. If we look at C and we look at B and we use this formula, negative C over B, and that tells us the phase shift. Finally, if the graph is going to be shifted up and down, we're just going to be looking for the vertical shift, which is going to be this letter D. Okay, so one of the things that we're going to do is we are going to take a look at a number of sine functions, and we are just going to employ those formulas to be able to find the amplitude, the period, the phase shift, the vertical shift, and any reflections. Then what we're going to do is we're just going to use technology to graph both functions on the same graph, just to see what they both look like. All right, so we have this function, 3 sine of 2x. Now, another way to write this would be 3 sine of 2x plus 0 plus 0, okay? And the reason I do that is because, well, I still need to figure out what C and D are to be able to find some of those other functions. So in this case, A is 3, B is 2, C is 0, and D is 0. Okay? So when we're doing this problem, we know that A is 3, B is 2, C is 0, and D is 0. So for part A, if I'm looking for the amplitude, well, the amplitude is the absolute value of A, which is going to be 3 in this case. Okay, so basically what that means is that the function is going to go all the way up to 3 and down to -3. All right, and we'll see that when we graph it. Okay, the period. Okay, the period is pretty easy to find. Okay. Or the formula for period is going to be 2 pi over b, right? And so that's going to be 2 pi over 2, or pi, right? And so what that means is that this function is going to be, it's going to basically go through its period a little bit quicker, okay? In fact, twice as fast. The phase shift. So our phase shift is going to be the opposite of c over b. Well, in this case, c is 0, so it's the opposite of 0 over 2, which is going to be b, otherwise known as 0. Okay, so basically it doesn't shift left or right. Vertical shift, we know that d is equal to 0. Okay, so there is none. Okay. And then finally, we notice that 3, it doesn't have a negative in front of it. Okay, so since A equals 3, which is greater than 0, okay, there is no reflection. Okay, so now what we can do is we can go ahead and we can just go ahead and graph these two functions just to kind of see what's going on with this. Okay, so I'm going to plot the original sine function, and then I'm going to plot 3 sine of 2x on the same graph. Okay, so We have y equals sine of x, okay? And let me just go ahead and zoom in a little bit, okay? This is about one period, okay? So what I'm looking for is I'm just kind of looking at one period of the function, okay? So obviously the period stops here. Now, the other one that we had was y equals 3 sine of 2x, all right? Now, notice what happens is the highest this function gets is 3. The lowest this function gets is negative 3. Also, to go up, down, down, up, it takes a period of pi. Okay, so that's what we're doing with this. Okay, this function just doubles the periodicity. Okay, or actually it cuts it in half. It just takes half the amount of time or half the distance for it to go through one period. And then the amplitude is 3 times as high as the regular sine function. Okay, so we can see that pretty easily. Now, another example, a little bit tougher, but not much. We have this 1/2 sine of x plus pi thirds. And let's put a plus 0 at the end here. If I'm identifying A, B, C, and D, A is a half, B is 1, because that's the coefficient of the x, C is pi thirds, and D is equal to 0. Okay, so if somebody were to ask me what the amplitude of this would be, that would be the absolute value of a half, which is a half. Right, so basically what that means is that this function is going to be half as high and half as low as the previous. For the period, that's going to be 2 pi over b, or 2 pi over 1, which is 2 pi. All right, so it's going to take the same amount of time to go through. For the phase shift, okay, that's going to be the opposite of c over b. Okay, so this is our formula. We haven't seen a phase yet. And so for our phase shift, that's going to be the opposite of pi thirds over 1, or negative pi thirds. And so what that means is the graph of the function is shifted left pi thirds of a unit. Okay? D equals 0. So what that means is that there is no movement up or down. Okay, so no vertical transformation. And then finally, for letter E, A equals a half, which is greater than 0. So there is no reflection. Okay. All right. So once again, let's see what the graph of this function looks like. Okay. So we're going to plot them both on the same graph, and we're going to see what this function looks like in comparison to the original sine function. Okay. So we have 1/2 x plus pi thirds for sine. So we have 1/2 the sine of x plus pi over 3. All right. Now, I want you to notice that the highest that this function goes to is a half. Okay, the lowest it goes to is a half as well. Right? Also, if you notice how long it takes to go through, okay, this function actually takes pi to go through. Now, it's actually shifted a little bit to the left. Okay, so instead of starting at 0, 0, it starts at negative pi thirds 0. If I add 2 pi, that's 5 thirds pi, or 5 pi over 3. All right, so over here, this is the end. Okay, so this from here, and I'm going to trace it along all the way over. This is one period from this black dot to this black dot. Okay, and notice that we're not moving it up or down at all. Okay, so that's how we want to try to just visualize what these things look like in our head, these functions. Okay? A third example, we have negative 4 sine of 1/2 x minus pi plus 1. Okay, identifying A as negative 4, B as a half, C as negative pi, and then D is going to be equal to 1. So going through this, okay, and then we'll graph them both. We know that the amplitude is going to be the absolute value. Okay, so our amplitude is the absolute value of negative 4, which in this case is going to be positive 4. Okay, so the function is going to go up to 4, down to negative 4. For our period, that's going to be equal to 2 pi divided by b, or 2 pi over a half, which is the same thing as 2 pi times the reciprocal, which is 2 over 1. And so our period is 4 pi. So this function is going to take a long time, actually it's twice as long as the original function, this original sine function, to go through a period. Phase shift is given by the formula negative c over b, and that's going to be the opposite of negative pi over 1/2, and that just ends up being positive pi times 2 over 1, or 2 pi. The vertical translation is up 1, okay, and that's just because d is equal to 1. Right? And then finally, the last thing we notice is that there's a negative in front of a. Okay, so a equals negative 1, it's negative 4, which is less than 0. And so that means we reflect in the x-axis. Right? Now, if we were to plot this, okay, so let's just go ahead into our graphing calculators and plot that function. Okay, so it was negative 4 sine of 1/2 x minus pi, and then plus 1. All right, now I'm going to have to zoom out some, but first of all, I want you to notice that it actually goes up to 5, okay? And that's because the amplitude is 4, but remember we shifted up 1 unit. That also means the lowest point should be negative 3, okay? So we just add 1 to whatever that highest and lowest point are because of this vertical transformation. I want you to also notice how long it takes to go through one period. Okay, so go through one period of this animal, which starts right here and then goes all the way over to here. Okay, that's a long time to go through. Okay, so if we were to add 4 pi onto this, okay, that's basically telling us what would happen. Okay, also the phase shift is 2 pi. Okay, so we just shifted the function over 2 pi. All right, so again, that's what our function looks like. It's a lot longer than one of, or at least one period is a lot longer than the original function takes. Okay. All right, one last example. We have this negative 1/3 sine of 2x plus pi fourths minus 3. Okay. Identify A, B, C, and D. A is negative 1/3. And we know that B is going to be 2. C is going to be pi fourths. And D is going to be equal to negative 3. And so amplitude is going to be 1/3. Okay, so for A, our amplitude is going to be equal to the absolute value of negative 1/3, which is going to be 1/3. All right, so we have a pretty low function with this. Okay, so, or in other words, it's going to be pretty close together, the sine wave. Okay, for our phase shift, remember, I'm sorry, not phase shift, but the period. Our period is equal to 2 pi divided by b, which in this case is going to be 2 pi over 2 pi. I'm sorry, 2 pi over 2, which is just going to be pi. Okay, so it's going to be a little bit faster for us to go through this function. Phase shift, negative c over b. Okay, so our phase is going to be negative c over b. C is going to be negative pi fourths, and we divide that by 2. Now we have to be careful with this, all right? When we simplify it, that's going to be negative pi fourths, okay, so this should be a 4, times the reciprocal of 2, which is 1/2. So the phase shift should be negative pi eighths. For the vertical transformation, that's going to be down 3, okay? And that's just because we have a d equals negative 3. And then finally, since a is less than 0, there's going to be a reflection. Okay, so reflect in the x-axis just because a equals minus 1/3, which is less than 0. All right, so given all of that, let's go ahead and plot this function. That'll be the last function we plot in this video. So in our graphing calculator, we have a negative 1/3, and then we had a sine of 2x plus pi fourths. 2x, and then pi over 4, and then we had a minus 3. All right. Now, a few things to note, okay? Number one, notice that the amplitude is not high at all, okay? So it just basically spans from, and we also shifted down 3 units, okay? So notice it's been translated down. The period, remember we said the period of this thing was pi. So it actually goes through a period pretty quickly, okay? So it goes down and up and down and up, okay? So down, up and down. So the period is pretty quick for this thing, okay? Where over here, the period just goes through, and remember it's 2 pi, all right? So this goes through pretty quickly, okay? The period's only pi. And then also notice that we have a little bit of a phase shift, okay? So usually like this would be the lowest point, okay? But remember, if you look back over here, we have a negative pi eighths. So it actually got shifted just a little bit to the left, and then it also got reflected. So this point would usually be the lowest point. It's actually the highest point now because of the reflection in the x-axis. All right, so that's our functions of the graphs of the sine functions. That's how we can translate these. So in our next video, we're going to do the exact same thing that we did in the first video. We're going to go ahead and get the basic cosine function graph. And then from there, what we'll do is we'll look at these transformations. These rules are going to be the exact same for the sine function or the cosine function as well.